All right, so in this module, we're going to be covering Chapter 17 and Chapter 18 of your textbook. Chapter 17 goes over troubleshooting, and Chapter 18 goes over advanced management tools. Troubleshooting is one of the really important things I think a IT person in general can have, whether you're a programmer or a support specialist or a systems administrator. If you've got good troubleshooting skills, you've got really marketable skills for finding a job later on. So hopefully the content of this module will help uh, direct your learning in terms of troubleshooting. You can actually apply a lot of the concepts we're learning to things outside of the IT realm. So for example, working on your car or working on your house or doing some project around your home. A lot of things in life require troubleshooting, and hopefully this will be a worthwhile module for you. So let's talk about Troubleshooting 101. This is the methodology I usually like to use when I'm going through troubleshooting a problem. So the first step is to gather information. So as it pertains to Windows or computers rather, you want to look at the error messages that you're getting. They're often very helpful in determining what the problem is, and they help guide you towards the solution to the problem. Most of the time they do that. Sometimes you'll get cryptic error messages, but most of the time you'll get error messages that are helpful. Also look at the hardware and software details. So, what kind of computer is it? What application is causing the problem? Is there any sort of application that's running in the background that might be interfering with the application that's throwing the error message? So it's important to gather the hardware and software details. And Windows has a lot of ways that allow you to do just that, to gather information. So we're going to explore that in a few slides. So next, always start with the basics. So for computers, the old cliche is, have you tried turning it off and on again? But those of you that have done any sort of troubleshooting on computers know that that solves a lot of your problems. And that's just because sometimes processes get hung, software can interfere with other types of software, so sometimes rebooting is just the best way to go. Also check other things like, does it have power? Is it plugged in? Things that are basic, really quick fixes that typically will encompass a lot of the problems. Definitely start with there, and then work your way to the more complex fixes. This one's really important, and this one is one that's often overlooked. Only make one change at a time. So oftentimes when you're in crisis mode, server went down and you're trying to figure out why it went down, and all your users are lining up at your office door to tell you the same thing. Hey, this isn't working. This isn't working. Oftentimes, newer technicians will start to panic, and they'll try a bunch of different fixes, hoping that one of them will fix the problem that you're having. I like to call that the shotgun approach. You want to be more directed. So it's important, even if you're in a panic crisis situation, that you only make one change at a time. And moreover, keep track of the changes that you're making. So say, for example, your car breaks down and it won't turn on again. So you might start by checking to make sure that the battery works. If the battery doesn't work, move on to the next thing. So you don't want to pull your whole engine apart and reassemble it with new parts just to find out that the battery was the problem. So make sure that you're only making one change at a time and not a whole bunch of different changes. Moreover, if you are making a bunch of different changes at a time, chances are you're not going to be able to figure out what the problem was in the first place. So when the problem inevitably happens again, you won't be able to figure out you won't be able to figure out with any sort of precision how you fix the problem in the first place. So next step, make a list of probable issues and eliminate them one by one. So this is usually easier said than done, but just before you start troubleshooting something, it often is a good exercise to think about what you think the problem might be and what the solutions are, and then just go through and fix things one by one. If you ever get a chance to go look at some TechNet articles, which you may in the course of this class, you may note that there's 6 or 7 different fixes for an error message that might pop up. So they have you walk through each one of those fixes one by one until you've figured out the problem and the solution. So it's usually helpful to make a list of issues, or excuse me, a list of probable issues or probable causes to your issue, and then eliminate them. Last step, excuse me. So this is one that I think a lot of technicians, a lot of people in IT tend to have a little bit more of an arrogant attitude, I guess you could say. And I know I have this every once in a while. I'll get so zoned in on a solution trying to fix it, or an issue and trying to fix it, that I don't take the time to ask for help. Oftentimes in IT, there's a lot of stuff to learn. There's a lot of stuff to know. And sometimes people are just really hesitant to reach out for help when they don't know the solution, and that's okay. Everything is there's a whole bunch of stuff to know. I like to tell the story that during a job interview, one of my friends went through. They asked him to do some really esoteric thing on a Linux server, and he couldn't quite remember the syntax of the command he needed to enter to do the thing that they were asking him to do. And so he's kind of fumbling around, and what they ended up, what one of the guys interviewing him ended up doing was leaning over to him and said, "Hey, it's okay if you need to Google this. We all cheat." And that's totally true in life, or especially in life as far as IT systems administrators and technicians go. No one can know every single thing, and it's really important that you reach out for help when you need it. So those are the troubleshooting 101 steps. It's again usually good to follow these from start to finish, and again, most important one is, if you go all the way through these steps and you still can't figure it out, always make sure you reach out for help. So in the last slide, we talked about gathering system information, and Windows has a multitude of tools, or many different tools, that you can use to figure out information about your system. So this slide, we're going to talk about those different tools. So you can gather information about the system you're working on in a number of different locations in Windows. The System section of the Settings menu displays some basic system information, and we're going to take a look at that here in just a second. There's a command line utility that you can run called systeminfo.exe, and it's a command line utility that will display some more system information. What's really useful about this utility is that you can use it for scripting and automation. So, let's say you have a lab of 30 different computers, and you need to pull the processor information from all 30 of them. You can use systeminfo.exe in one of your scripts to grab that information. The final one that's really useful is msinfo32. So this is a GUI utility, so graphical user interface utility, that contains the largest amount of information about a system. So it's just a ton of information, and we're going to see this here in a second. The easiest way to find it is to use the Windows search function. So in the previous slide, I mentioned that there's several different utilities that Windows has available to look up system information. So again, this is often a great first step when you're starting your troubleshooting process, just to gather information about the machine you're working on, because not every machine is created equal. So the first utility that we're going to look at is the Settings menu. So we'll click on Start, then we'll click on Settings, we'll click System, and then we're going to click on About. And this is going to give us probably the most common information that you'd want to pull from a particular computer. So starting from the top, we have the PC name, we have the organization, so if it's part of a work group or part of a domain environment, which we'll get to in a few modules. It gives you the edition of Windows 10,
Same thing with the version and the build. These are really handy, especially with Windows 10, because we have a whole bunch of different versions and builds out there now. And oftentimes they have different features from one another. Same thing with the addition of Windows 10. Pro, as we discovered in lab or module 1, Windows 10 Pro has different features from Windows 10 Home. So it's often helpful to figure out which edition of Windows you're working with and which version of Windows you're working with so that you can kind of gauge what sort of utilities and access you have. It also shows you some hardware information, so the processor and installed RAM, and if you're running a 64-bit or 32-bit machine. So that's the settings menu. So I mentioned that there's another utility. This would be the command line utility systeminfo.exe. So to get there, we're going to click Start. We'll click on command line, or we'll search for CMD, and we'll go ahead and launch it. And then all we have to do from here is type systeminfo.exe, and that's going to look up some information about our system. So here we can see we have a lot of the information that we saw in the previous utility. So we've got the host name, we've got the operating system name, we've got the system manufacturer, system model. We can see that this is running in VirtualBox, so this is a virtual machine. We can see how many processors we've got. We can actually see when the operating system was first installed, original install date. So we can see I installed this on January 6th of 2017. It even gives you the time too, so if you want to get really granular, you can. So I mentioned before that this is a scriptable utility, which means you can take the output here and you can put it into your own custom scripts. So say, for example, we wanted to figure out only the memory fields here, so physical memory, virtual memory, so on and so forth. We could actually take the output here and then we could put it into another command so that we could easily search for that information. And we could even force this command to run on other machines if we really wanted to. But let's just take a look at how we can manipulate this with a script. So systeminfo.exe, we'll take that command, we'll use the pipe command, and then we'll use the find string, FINDSTR command. So systeminfo.exe, if we just run it, we'll display the output we saw. The pipe command here is going to take that output and then use it as input for this find string command. So to use the find string command, we'll type FINDSTR, and then we'll type a search term. So in this case, I'm just going to search for the word memory. And then what's going to happen here, or what should happen, is we get output that just shows us the lines that have the word memory in them. So let's go ahead and run it. And you can see instead of outputting all of that, we get just this here. So that's just one way you can, real simple way of sorting and filtering the results from here, but you can see how that could be added to a much larger script to give you more information. So that's the systeminfo.exe utility. There's another there's another utility that we can use to gather more information called msinfo32. So to get there, we'll just hit start. We're just going to type msinfo. And you can see here that it's listed as system information. That's just the Windows 10 rebranding. It's still systeminfo32. So we're just going to go ahead and click on it, and it's going to launch this application. Now you can see we've got a lot of the same information that we did before on this one page. So total memory, pretty much everything that came up with systeminfo.exe. But this is just the system summary page. Now each one of these categories can be expanded upon. So we can see things like memory resource identifiers, IRQs. We can see I/O devices and what their status is. This is a lot more granular information that most technicians will even get into, but this is something that we can use to gather more information about our machine. So this is another utility that you should go through and play with this week. Just one real quick feature Remember how we used the find string command in the previous utility, systeminfo.exe, to find a particular string? Well, we could do the same thing here just by typing memory and then clicking find. And then it's going to find us all of the values that have to do with your memory. So random access memory in this case. So those are the three utilities that are used most, I think, in Windows to gather system information. Now there's a ton of other utilities that we're going to take a look at that give us more granular information about other aspects of your machine. So stay tuned for that.
So let's talk about Windows services. So Windows services are programs that perform some sort of supporting function and they run in the background without user interaction. So they're kind of like the unsung heroes of your operating system. They're the things that make things happen, in other words. So for example, you all have probably heard of the term Bluetooth before, and just in case you haven't, Bluetooth is a service, or rather Bluetooth is a technology that most computers have now that allow you to connect Bluetooth enabled devices or peripherals with your computer. So you might have Bluetooth mice, Bluetooth keyboards, things like that. Well, typically accessing or connecting Bluetooth devices is done in the background. There's not a whole lot you really have to do once a device is paired up with your computer other than turn it on and start using it. And so there is a service called the Bluetooth service that runs in the background that handles all of that. So again, most of the time users don't interact with that service. But it is necessary to perform the supporting function of enabling Bluetooth access on your machine. So Windows services are often run with the system user account, but they can be run with any user account. So if you have a particular service that requires a user-created service account, sometimes software or even hardware will make you create a new user account whose sole purpose is to run that particular service. You can actually change the context in which that account or that service is running it. So services are managed several different ways. You can create what's called a Microsoft Management Console. So we'll take a look at that here in a future slide. And you can add it as a snap-in. You can control it through the control panel, or new in Windows 10, you can manage services with a task manager, which we'll look at here in a second. It's important to note that services can be dependent upon other services to function. So let's talk about that Bluetooth service for a second. Let's say in order for the Bluetooth service to function, you also needed, and just for the sake of example, you needed service X to be running in addition to the Bluetooth service. So if service X was not running, the Bluetooth service wouldn't run. So if you turn off service X, that also will turn off the Bluetooth service. However, if you turn the Bluetooth service off, that doesn't necessarily affect service X. So there's a little bit of a hierarchy sometimes when you have services that rely on each other running at the same time. So it's important to note that services can depend on other services to function, and if you turn a service off, typically it'll tell you if it has any dependencies, but it's important to note if it does or not so that you don't inadvertently turn something off you shouldn't. Services have three different states: stop, which stops the service completely; start, which starts the service if it's stopped or paused; and pause, which basically just suspends the service. Pause is generally not used super often, or very often, but it's there just in case you need to pause a service. So it's sort of like putting your machine to sleep. It still uses some system resources, but it suspends whatever it was doing.
So let's take a look at the services menu. So I mentioned there was several ways you can get there. One of the easiest ways to do it is to just click Start and then type Services. And we're going to look for an icon that looks like this. So it's just gears. So this is going to pop open our Services Management Console. You can see here that we're managing these services on our local machine. And we have a list of all of the services that the computer is currently running or could run. In the left-hand column here, we have the name of the service. You can note here that it's not just Microsoft that has services that run on your machine. So for example, we have the Adobe Acrobat Update service, which based upon the description here, is there so that it keeps Adobe software up to date. So this will be like Adobe PDF, Reader, things like that. Now, if this service was not running, we would see the status blank here. Otherwise, it's going to show the status is running, stopping, or it's going to show paused. So if we wanted to, let's say we did not want the Adobe Acrobat Update service to be running right now because it was interfering with some other service that we had, we could right-click it, and then we could simply just say stop. And then that's going to stop that service from running. So basically what that means is it's not going to perform this function of keeping our Adobe software up to date. Sort of like basically what we did there is it's almost equivalent to you going up to any application and just clicking the X, the red X in the top right hand corner. It just closes it out or stops it from functioning. Now if we wanted to start it again, we could right click and say start, and then that's going to start the service. Services have a startup type. So some services you want to run as soon as your machine starts, and other services you might only want to run for a specific period of time, or you might want them to be triggered by something. So one we can look at here, we have the BitLocker Drive encryption service. So this is only triggered when we enable BitLocker on our machine, which is full disk encryption. Since we don't have a trusted platform module and we're running in our test VM, I don't have this enabled. So it doesn't make sense for this to run because I don't have BitLocker running. But if BitLocker was running, we would likely come back in here and we'd be able to see BitLocker encryption service with the status of running. The last column here shows you the security context that the service is running as. So similar to how you have to sometimes run a program as an administrator, sometimes you also have to run services as an administrator. So we can see here we have local system, which is basically, it can act as a higher level of administrative power than your administrator account can. Which is why we see a lot of services running as the local system service. But let's say we had a service that we only wanted to run within the context of the user account that we have. We could do that as well simply by right-clicking the service, clicking Properties, and then going to Log On, and then selecting a specific account. So if I wanted this work folders service to run only under my security context, so this is, we're running under my account here, Tim, which is a local administrator. We could come back into the services console, again, click properties. We could click browse. I can type Tim, click check names to make sure that that works. I'd put in my password here, and then I'd click OK, and that service would only run under my security context. Now you have to be careful about this because if your security context does not have the correct permissions to run the service that you're running, then the service is going to error out most likely. So we're going to cancel that. Last thing I want to show you here, we can go into recovery. So this tab is basically, I guess there's two things I want to show you. So the recovery tab here, if we right click a service, click properties, and then recovery, this is going to basically tell Windows what to do when the service fails. So sometimes services will fail. This is oftentimes why we have tell people to turn their machine off and on again, because services will fail. And oftentimes they're set to take no action when they do fail. That's not necessarily the fault of Windows. It just basically means that the application administrator decided that there should be some sort of manual, or the application developer decided that there should be some sort of manual intervention when the service fails. So in this case, let's say this work folders properties folder or service failed. We could click restart the service, and then that's going to restart the service for us on first failure. Same thing with second failure. We could set that to do whatever we want. So maybe we set it to automatically restart the computer when it fails. And then anything after the second failure, we can set it to do other things as well. We can also enable it to run a program when the service fails. So maybe we have a script that will email us when the service fails. So there's a bunch of things that you can do in here as far as recovery. The last tab I want to show you is the dependencies tab. So I mentioned that some services have dependencies, meaning that they rely on other services to function. So in this case, we can see here in this top box, this service depends on the following components. So remote procedure call, RPC, and Windows search. And if these are not functioning, if they're not running, then this service is not going to be able to start as well. Now if we go to remote procedure call, so we'll just find that in the list, RPC, remote procedure call, we can see that the status is running. And if we click on its dependency tab, we can see that that work folder service is listed under here. So this is saying that the following system components depend on this service, and work folders is one of them. So that's the services console in a nutshell. Again, I encourage you to go in here and see what you can do with the services, play around with them, explore. I believe your lab this week has you go over services specifically pertaining to the firewall, so you can see how turning off a service interacts with some other component of Windows.
Okay, so let's talk about the task manager. So the task manager is basically like the Windows administrator or a Windows technician's bread and butter. It basically, what it does, we'll skip down to the second bullet point here, is it provides information about the computer, a lot of information. So like performance information, what software is running, and it even shows the status of the service. The task manager in Windows 10 has been enhanced from previous versions. So new features include displaying the IP address of each interface. It used to not do that. You'd have to go into the command line to figure that information out. You can use it to manage startup applications. So if you don't want a particular application to start up, you can do that. That was a feature that was rolled into the task manager from previous versions of Windows. You can also use it to see enhanced performance information. So it actually shows you new graphs, color coding, and metrics. And then in addition to the services menu being its own thing, you can actually interact with the services menu via the the task manager. So all four of these bullet points here, all of these used to be their own separate application. And now they're all rolled into one, which is really great. It sort of becomes a one-stop shop for looking at tasks in your task manager. You can use the task manager, you can use that should say task manager. You can use the task manager to kill running tasks and apps, or you can disable startup applications, or you can turn services off and on. So in the next slide, we're going to take a look at how to do that with the task manager.
So there's a couple ways to get to the task manager. I think the easiest way, though, is to just right-click the taskbar and then select Task Manager. Alternatively, we can also press Ctrl-Alt-Delete on our keyboard, and then we can select Task Manager. And those are the two easiest ways to get there. So let's just go over what you can do in the Task Manager. So the Processes tab allows us to take a look at what is running on our machine. Now this has been enhanced from previous versions of Windows. It used to be that you'd only get a list of processes and some various performance information. Now it allows you to see out of the 4 major components of your machine, how much of that particular component that service is using. So in this case, we can see that Cortana, that is using 6.1% of our active memory just to sit at idle. So it's using a considerable amount. We can also sort these columns by simply clicking on them, and we can see which one of these applications or processes running is taking up the most resources by component. So in this case, we've sorted the CPU, or we've sorted this list by the highest CPU usage. Ironically, the task manager right now is taking up the most system resources in terms of the CPU. However, if we click memory, we can see that Cortana is taking up more memory just sitting idle. So this is really good to identify applications that may be causing your computer to slow down. Sometimes what you'll see is the memory will be sitting at 100%, and then one of these applications may be using a ton of that memory, or the vast majority of it. And if you kill it, then suddenly, or if you right click and select end tasks, then suddenly the computer starts to function fine. So when we talk about performance monitoring in a few labs, we'll talk about the concept of a bottleneck, and we'll revisit the task manager with that in mind. But just keep that in the back of your mind for now. If we wanted to end a task, so say I kind of showed that already, but say we discovered that there was an application that was taking up too much resources. In this case, we'll say it was the task manager. We could right click it and we could say end task, and then that would close it. Pretty easy, right? Other things you can do in here, if we were to right click an application, let's say Cortana, we could see information, or we could sort the Cortana information by values instead of percentages. So in this case, instead of seeing the percentage of the memory it's taking up, we're seeing the actual amount of memory that it's taking up. So in this case, 64.1 megabytes. We can do other things like look at the properties for that particular service, so we can see where that service is executing from, so C, Windows, System Apps. We can see what the security looks like on that. Same thing with sharing. If it's a service that can be shared or a folder that can be shared, we can see that there too. We can also click the name field to sort the application, or to sort the apps or background processes you have running by name. Let's look at the performance tab. So if we click performance, we actually get a whole bunch of different information available to us, and this used to be all rolled up into one feature called the resource monitor. The performance monitor or the resource monitor, which we'll talk about here in a second. In fact, you can still see a link to the resource monitor right here in the bottom left-hand corner. So each one of these components is kind of like the major input-output component of your machine, or one of the major input-output components of your machine. So we can see here we have the CPU, we've got the memory, we've got the disks. So I have 4 disks in this machine, and we've got the Ethernet status. And this just gives you a graph of the overall performance of that particular component. So we can see here that we are utilizing about 11% of our processor. We can see what speed our processor is running at, how many virtual processors we have. If we're running in a virtual machine, this one's really handy. We can see what the uptime of our machine is. That one is particularly useful because users don't often listen to you when you say reboot your machine. And so this is a good place to check to see if they've actually rebooted their machine. So checking to see if their uptime is, uptime being how long their computer has been running. Just a good way to see if they've rebooted as you asked. Now if we click on memory, we can see that we get some more information. Or some different information here in the bottom. And that's just because the memory usage is fundamentally different from the processor utilization. So we get some different metrics or statistics down here. We can click on the App History tab, and we can look at the CPU time, network, bandwidth that each app is taking up. Now keep in mind that in Windows 10 terminology, apps are different from applications. So apps might be like the thing you use to launch your your camera on your computer to take a picture. Applications would be like Microsoft Office or Adobe Acrobat. They're a little bit different. So here we can actually manipulate some of the apps in certain ways. I don't want to spend too much time on this, so I just wanted to make sure that you are aware that the App History tab exists here. Startup here, so we can see which applications launch upon startup. So you can see I don't have a huge amount of applications installed on my machine. Windows Defender is something that comes with Microsoft by default, or Windows by default. Same thing with Microsoft OneDrive. So if we wanted to disable Windows Defender notification service, or the notification icon from starting on startup, we could just simply right click and say disable, and that would prevent that application from starting up. It's really useful for troubleshooting things that might be programs that might be causing issues on startup. For example, I ran into a computer not too long ago that had Norton antivirus installed on it, and the computer was underpowered and couldn't really handle running Norton antivirus. So, so what I did is I came in here, I disabled Norton from starting up on startup, I rebooted the machine, and then lo and behold, the system was functioning perfectly. So that was how I was able to identify that Norton was the cause of the performance issue. If we click the Users tab, we can see by user who's taking up the most system resources and what applications they're running that may be taking up the most system resources. So one of the cool things about Windows 10, and heck, even older versions of Windows like 7 and 8, is that you can have more than one user logged in at the same time to a computer. And that basically allows you to keep applications running. However, sometimes one user may be taking up more system resources than another user, so you might have to come in here just to figure out if that's the case or not. We can click on the Details tab to get some more detailed information about the processes on our machine. Starting with the left, we've got the name of the application. And this is the short name, so sometimes these are a little bit more difficult to figure out what they are. So here we can see we've got Foxit, but here we've got something called SVC host, we've got VBox service, and that's not necessarily helpful in determining what that application actually does. So that's why we've got the description field over here. So in this case, like for Foxit, we can see that this is the Foxit connected PDF Windows service. We've also got the PID, which is the process ID. So if you ever need to kill a process from the command line, sometimes you'll need the PID instead of the short name just to kill the process. You can see if this process is running or if it's suspended or stopped. Depending upon what's going on with that application, it might it might be suspended or stopped. If it wasn't running, it just wouldn't show up in this list here. And then finally, I mentioned that we have the services menu. So that same services menu we looked at before is also available here. With one caveat to that, this is showing the short names and the process ID for each thing. It's not showing the long names. So sometimes it's difficult to see or to figure out which service it is just based upon the short name here. So again, the description column is going to be really handy in figuring that out. So the Windows Defender service, that's what we're looking at here. If we wanted to stop that, very similar to the previous menu we looked at, we could right click and we could just say stop, and then that will stop the Windows Defender service. Now sometimes you'll run into this access denied error message. This is because I did not run the task manager as administrator. If I did, I'd be able to kill that service, but since I didn't do that, I'm not able to do that now. So that's pretty much the task manager in a nutshell. Again, this is like a bread and butter tool for Windows administrators. So it's definitely something to get acquainted with. So if you haven't played around with the task manager, definitely do so this week.
So the reliability monitor is a new feature with Windows 10. Basically what it does is it assesses the overall stability and reliability of your system. And then based upon that, it assigns the system a score between 1 and 10, and then you can use that to easily determine how quote-unquote reliable your system is. So it assigns this score depending upon the number of errors and the type of errors experienced on your system. So, for example, let's say you have a machine that has some sort of a memory issue, and it keeps getting the dreaded blue screen of death message. Then you'll be able to basically what will happen is it will have a lower score than a comparable machine that didn't have any sort of blue screen of death messages popping up all the time. So this can be a good way to figure out if a system you are working on has some sort of performance issues, or if it has some reliability issues. You can pop open this utility, and then you can see what Windows thinks the reliability of this computer is. It does track and display errors over time, so you can actually go back, and it can be a little bit more user-friendly than the event log to see what errors look like or what errors have occurred over a specific time period. And this is a tool that is available in the control panel. So we're going to take a look at this here in the next slide.
Okay, so let's take a look at Reliability Monitor. So it's actually one of those utilities that's a little bit harder to find. So the easiest way to do it is to just search for it. So we're just going to search for reliability. And then we can see this option here comes up in the control panel. In the control panel, there's like 7 different layers you have to go through in order to access the reliability history. So by far, this is the easiest way to search for it. So at this point, what you get is you get a graph that shows you the time on the horizontal axis. And on the vertical axis, it shows the score that your machine has at that given point in time. So we can see here up until April 12th, 2017, this PC was performing at a 10. And then we had some sort of error on April 12th, 2017. So we can click into this day and we can actually see what caused the score to drop. So here we can see that we had some sort of critical event stop working. Looks like our malicious software removal tool stopped working. So depending upon the software that died or the software that had an issue, you might get a critical event, you might get a warning, or you might just get an informational event. And this is really echoed. It's very echoey of the event viewer, which we'll take a look at here in a bit. But critical events, as the name implies, is they are events that are critical or something that you should probably investigate. So in this case, I should probably take a look and see why the malicious software tool stopped working. Now, one of the cool things you can do here is you can click the check for a solution button, and then this is going to go out and it's going to try to find if there was a quick and easy fix for this particular error. So in this case, we see that there was no solutions found, which is pretty common. This doesn't always work, but it's something to try. Sometimes it'll fix your issue. We can see under warnings, we have an Adobe Acrobat PC Reader warning. Looks like there was some sort of reconfiguration that was going to be done and it wasn't able to do it. If there's no option to check for a solution, which typically there isn't in the warnings and informational events, you can click View Technical Details, and then that will pop open a description of what was happening at that point in time. So overall, the reliability monitor is a pretty useful place to look just to see when kind of the timeline of when your system started performing, when your system had things that may have gone awry. So, in this case, we can see that on the 12th, there was something that had gone awry, and we didn't have any sort of events until the 20th, and then we had some more things that happened. So in this case, Windows didn't shut down properly, and Internet Explorer stopped responding. So again, these are varying levels of criticality, I guess you could say. So it may or may not be worth exploring it depending on what the issue actually is. So you'll have to do some research into figuring out exactly what the problem is and if it's worth exploring. So that is the reliability monitor in a nutshell. It's pretty straightforward, I think. And again, another tool for you to look at this week.
So let's talk a little bit about the event viewer. So the event viewer is a much more robust version of the utility we just looked at, the reliability monitor. It is an application that displays a log of application and system messages. So in other words, if you ever hear anyone refer to, oh, go check your log, or go check your event logs, or go check your logs in Windows, this is typically what they're referring to. Now that's not to say that applications can't keep their own event logs, but Event Viewer is a pretty common repository for events in Windows. So the event log, or Windows Event Log service, writes data to the event logs. So just kind of going along with our services concept, the Windows Event Log is a service. It does require administrative privileges to run. So if you are not an administrator, you won't be able to access the event log. It can be viewed as an MMC snap-in. Microsoft Management Console is what MMC stands for. Again, we'll talk about that here in a few minutes. The event records are split into several different log files. So we have application logs, which store, surprise, logs related to applications on your computer. We've got security logs that store information related to security, so log on, log off events, when files were accessed, so on and so forth. Setup logs, these are events that happen when software or Windows updates happen. You'll be able to look in the setup logs and you'll be able to find out if anything had gone awry during the setup. System logs have to do with logs related to the operating system specifically. And then forwarded events, that's where you'll find applications that are making use of the event viewer. You'll find them write their log files to the forwarded events log file. So for example, you can set up Internet Explorer, which ironically isn't enabled by default to log. You can set Internet Explorer up to forward its events or its triggered logs to the event log, and it'll show up in the forwarded events. So continuing along here, events are logged as one of 6 categories. So we've got informational events, which we kind of looked at in Reliability Monitor. They are just events that are showing you that there's not necessarily something wrong. It's just showing you that the application or the operating system did a thing. So for example, a thing could include running a Windows update, could include when a file was accessed. So it's just informational events, so stuff that you can refer to later. Warning logs are, again, they're a little bit of a step up from informational logs. It doesn't necessarily mean that something went awry, but it's flagged so that you should take more of a closer look at it. Error event logs, the error category is one step up from warning. This basically is something that gets written to, or a type of log that gets written to the event log when there's an error that happens. So let's say you have an error message pop up, maybe access denied, or let's say, for example, you have an application crash on you. That can cause an error message, and that error message gets written to the event log. The next one is critical. So critical events are things that are system impacting. So we've all heard the term blue screen of death, or BSOD. That's what happens when Windows runs into an issue that prevents it from functioning and then forces a reboot. So the blue screen of death, and in Windows 10, these are called stop errors. Those will get logged as critical events. Success audit and success failure, these are other categories of events. So these will only show up in the security log, and these will show up when an object has either successfully authenticated itself or failed to. So again, I like to use the concept of accessing a folder. If you've got someone who is snooping around and they shouldn't have access to a folder and they try to access it, they'll get a failure event log written to the event logs, basically saying that, hey, this so and so tried to access this, they didn't have permissions. On the other hand, if you're an administrator and you have access to that same folder, you'll get a successful audit log written to that event log. So these can be used as an audit trail effectively. One other important thing about Event Viewer, event logs can be filtered for easy searching. So when we take a look at the Event Viewer, you're going to see that even on my vanilla version of Windows, I have maybe several thousand, at least several hundred logs that have been written already. Depending on how long your computer has been running, you might have thousands, hundreds of thousands of event logs, or even more. So those are things that the fact that you can filter the event log allows you to easily parse and search for the information that you're looking for.
So let's take a look at the event viewer. So easy way to get there, just go to your search function here in Windows 10 and type event viewer. And that's going to launch the event viewer console here. Now on the left-hand side, we've got a few options available to us. For the purposes of this class, we're just going to focus on the Windows logs, but there are other things you can do with the event log outside of the scope of what we're talking about this week. So here are the 5 different log files that we mentioned in the previous slide. We have application, security, system setup, and forwarded events. So if we click on the application log, we can see application log files that have been written to our log here. So you can see a lot of these are informational events. They don't necessarily require any sort of end user interaction. They're mainly just letting us know that, hey, something happened. So in this case, we can see that successfully scheduled software protection service or restart, and then it gives us the time and the reason. It gives us the time that it was logged, any sort of keywords that log file might need to be searchable later. Tells us if a user ran that or not, and a bunch of other different information here. We can right-click the event log and look at event properties to see some more verbose information. Sometimes it's verbose, sometimes it's not. And these are XML logs, so you can actually use you can use PowerShell to parse these a little bit more too. Again, I'm not going to take the time to go through each one of these because we talked about them in the previous slide, but just to take a look real quick, we've got security logs. Again, the security logs only show audit access or audit failure. Most of mine are successful here, you can see. And if we click in it, we can see exactly what that log or that event is telling us here. Same thing with system. You've got information, warning, error, critical messages, all different types of logs that we can look at. So let's say, I mentioned in the previous slide, we can have thousands of different logs. Let's just scroll down and just to illustrate how many log files have been written already. Quite a few, as you can see. And most of these are from today. So let's take a look at how we can filter the event log. So first thing we're going to do is on the right hand side here, we're going to click filter current log, and then this is going to pop open the filter. So let's say we only care to see any sort of errors that popped up. We can click OK, and then that sorts the event log by only error message or only events that are flagged with the error level. If we wanted to clear that, we could go ahead and click filter current log. We could uncheck that and click OK. So that's just a really easy way to find exactly what you need. If you had a blue screen of death a few hours ago or even a few minutes ago, you can filter the log. You can look for critical events, and then you can even say, hey, show me the information for critical events that were logged in the last hour. Fortunately for me, I don't have any, but if I did, they would show up here. So that's pretty much the event viewer in a nutshell. Again, this is another great utility you can use to do some investigating when you run into some sort of an issue with a machine. Definitely check the event viewer, especially if you get a blue screen of death. The event viewer can be really helpful in determining exactly what caused that blue screen.
So let's talk about some of the built-in troubleshooters for Windows. These are the things that will pop up from time to time depending on uh, what sort of thing went awry with your computer that will walk you through some troubleshooting steps. So they are wizard-based scripts that will correct commonly occurring problems with Windows. So one I can think of off the top of my head, let's say your computer can't connect up to the internet. You might get a troubleshooter that pops up that says, hey, let's walk through some common steps to troubleshoot the issue. So troubleshooters will be launched automatically when Windows detects a problem that it can potentially fix. So again, with that networking issue, you might get a troubleshooter that pops up and it might walk you through disabling and re-enabling the network adapter. Might run ipconfig, renew, a whole bunch of other stuff that will help diagnose the issue. Troubleshooters can be launched manually from the control panel. Some of the steps are performed automatically in the wizard, such as ipconfig, release, renew, while others are performed manually. So your computer can't interact with the real world in most cases, at least not yet. And sometimes you have to do manual steps. So for example, going back to our networking problem, it might direct you to look at the back of your computer to see if the network cable's unplugged. Now, troubleshooters will not solve all problems for you. They are meant to solve the most commonly occurring issues, networking trouble, things like that. But they will not solve all problems for you, and you shouldn't rely on them too heavily. But it is important to know that they definitely exist. So if you've used Windows, you probably run into this issue at one point or another, the dreaded blue screen of death. And if you haven't, consider yourself lucky. Blue screens of death can cause all sorts of things to go awry, and they're caused by a bunch of different issues. So let's talk a little bit in this slide about what a blue screen of death is, and what we can do about it. So stop errors are what they're referred to in Windows 10. If you ever take the certification test, typically you'll see the phrase stop error, and that basically stands for blue screen of death, or BSOD. So if you haven't received a stop error before, Windows will basically just abruptly stop and it will display a blue screen. That blue screen will have a whole bunch of text on it, and that text has varying degrees of usability. Most often what you want to grab while that information is up on your screen is the hex code. So you'll see a code that looks like 0x000AE0100 or something like that. And then you can use that hex code to figure out exactly why the blue screen was happening. So common causes for stop errors include physical hardware issues. So bad memory is very common. Hard drives starting to slowly die, that's also very common. Heck, even the processor starting to go bad, that can cause issues too. Malfunctioning hardware drivers can definitely cause problems. So again, just as a refresher, a driver is basically like the instruction manual that tells your computer how to use a particular hardware device. And if the hardware driver is malfunctioning or otherwise not working, then your computer, or the operating system, Windows in this case, doesn't know how to use that hardware device driver or that hardware device, and then will sometimes cause a blue screen. And finally, corrupted operating system files. We've all probably heard the joke, oh, what is that system 32 folder? I never go in there and I don't need that. And for those of you that don't get the joke, the system 32 folder is the folder where a lot of your operating system files are stored. So if you don't go in there, which typically the average user won't, and you start if you go in there and you start deleting files, then your operating system is just not going to function very well, or it's not going to function at all. So sometimes without those critical operating system files, your system's just not going to function, and it's going to run into blue screens. So during a blue screen, Windows, it does a better job of this now than it did in like XP or Vista. But basically what it does is it collects data during the crash, and then it stores it into the event log. Stop errors in the event viewer show up with the source bug check. So if you go back to the event log and you filter by not by type but by name, look for, or by source, excuse me, just input the text bug check and you'll be able to find that event. There are some third-party utilities out there that do a little bit better job than the event viewer of telling you exactly why your machine blue screened. So I'll leave that up to you to go out and find those. But there are definitely some utilities that help you parse that information a little bit better. But Windows Event Viewer does a pretty good job of it. So let's talk about what to do in the event you run into a stop error. So first thing to do, go ahead and look in the event viewer for records containing the source bug check, and then you're going to find that hex code we talked about earlier. So you're going to want to take that hex code, and then you're just going to want to take it and put it right into Google. So search the internet for the meaning of the hex code. So one of the great things that Microsoft does, and again, they've done a lot better of a job of this than they have in the past, is to maintain an exhaustive list of the stop error codes. Used to be you'd have to go to like a forum or just hope that someone else out there on the internet ran into the same stop error as you and also figured out the problem. But Microsoft has done a much better job in Windows 10 and I think Windows 7 and 8 of identifying specific stop errors. So typically, if you take that hex code and you put it into Google, the source of the error will pop up as well as the fix. So if that doesn't result in anything fruitful though, next thing you want to do is you want to identify if any hardware has recently changed. And if possible, revert that hardware change. So if you've added new memory, if you've upgraded the hard drive to an SSD, if you've added a new graphics card, those are all things that can cause the problem or cause your machine to blue screen. And you want to just make sure that you revert that change. Next thing you want to do is check your hardware to make sure that it's functioning properly. There are several tools Windows has to do this, one of them being check disk, the other one being the memory check tool. Both of these can be run via the startup recovery menu. You can also run the check disk tool for a non-primary drive right from the command line. So it's just chk dsk. You want to ensure that your drivers are functioning, so make sure you look in the device manager and double check that there's no yellow bangs. Make sure that your devices all basically say status go. Make sure that there's nothing disabled. Just ensure that your drivers are functioning properly. You want to check to make sure that the system isn't low on hardware resources. Some students have run into this with VirtualBox. So if you over provision your virtual machine for the class, so say for example, your computer has 2 gigabytes of memory and you give your virtual machine 2 gigabytes of memory, that's a good way to set yourself up for a stop error because you are telling VirtualBox that it can consume all of the system memory and that leaves nothing left for the host system. So sometimes there are applications that will start taking up all of your memory or all of a particular resource, and you want to make sure that the system isn't low on any of those. So the task manager that we looked at earlier is a good way to figure that out. Finally, make sure you run an antivirus scan. Malware can for sure cause stop errors. Typically, malware will interfere with the system files, and that can cause stop errors. So make sure that you run an antivirus scan. Again, antivirus is outside the scope of this particular lecture, but there are a ton of different antivirus solutions out there for you. So let's discuss the Microsoft Management Console that we've been talking about. So Microsoft Management Consoles are customizable consoles for administrative tools developed by Microsoft or third-party vendors. So it uses these utilities called snap-ins to add functionality to the console. So think about those various windows we opened up in the previous slides. So we opened up the Services Management Console, we opened up the Event Viewer, and we had to go to different areas of Windows to do that. But wouldn't it be really helpful if we had one utility that we could custom create that allowed us to access those quickly? It's basically what the Microsoft Management Console allows us to do. So you can save. One of the great things about the MMCs is that you can save and you can share them with other administrators and power users. So let's say you're a one-man IT shop and you go on vacation. You might create an MMC that the person covering your department can use to manage different computers on your network. It is stored as an MSC file. So if you ever see .msc, that's a Microsoft Management Console file. You can configure permissions on the MMC so that it runs in authoring mode or user mode. So authoring mode is basically a mode where you can create the management console and use it. But if you store it in user mode, that means that the end user can't make changes to the MMC. So again, going back to our vacation example, if you trust the user enough to manage some things while you're away, but you don't necessarily want to give them the keys to the kingdom, you might create a MMC and then save it in user mode so that they can't change the MMC. You can launch a blank MMC by simply typing mmc.exe into the start menu. And the great thing is you can use most snap-ins to manage remote computers. So one of the mantras I always try to live by as an IT guy is I want to be as lazy as possible. And what I mean by that is I want to be as efficient as possible. So if I have 30 computers that I have to manage and they are scattered all throughout a building, I don't want to have to leave my desk to manage those because that wastes my time. So using remote access tools or remote management tools like the Microsoft Management Console is definitely essential for productivity. So we're going to take a look at how we can use the Microsoft Management Console here in the next slide.
So to launch a Microsoft Management Console, all we're going to have to do is click Start, and then we're going to type mmc.exe. Then we'll click on this icon here. We'll say yes. And then this is going to launch a blank Microsoft Management Console. So you can see here it looks a lot like the options we looked at before, a lot like the consoles we looked at before. We've got kind of a menu on the left-hand side we can interact with. We've got a menu in the middle that shows us kind of more granular information about what that console is trying to show us. And then we've got some actions on the right-hand side too. So pretty boring by itself. But it gets a little bit more exciting when we start to add snap-ins to it. So again, snap-ins are basically just different consoles that we can combine into one console. So to do that, we're going to click File, then we're going to click Add, Remove Snap-in, or we could press Control-M on our keyboard to do that. It's going to launch a menu here, or a menu that looks like this. Then we can we can scroll through this list to find any snap-in we want to add. So this is a lot of the different consoles that are in Windows. If you have third-party applications that allow or that create snap-ins, they will show up here as well. So let's say we want to look at the two things we looked at earlier in the lecture here. We're going to click on Event Viewer, and then we'll click Add. Now it's going to ask us, do we want to manage the local computer, so the computer this console's running on, or do we want to look at the event viewer for another computer? So if we selected another computer, we'd be able to click Browse and input the name of another computer here, or the IP address of another computer. And then we'd be able to look at the event log on that computer instead of our own. In this case here, though, I'm going to say local computer, and I'll click OK. And then we're going to also look at the Services Management Console. So we'll click Add, click Local Computer, click Finish, and then we'll click OK. And now you can see here on the left-hand side, we have the Event Viewer and we have the Services. And in parentheses, we can see here that we are managing the local computer. If we were managing a remote computer, this would show up with the computer's IP address or host name. And then all we have to do to access the Event Viewer or the Services console is click on Event Viewer or Services. So basically it allows us to craft these custom consoles. So if we access one function of Windows more than another, so say we access the Services console, and we don't want to have to go through the process of start and typing services, we could create a MMC that allows us to quickly access all of the administrative tools that we might use. So to save this, all we're going to have to do is click Save As, and then we're going to save this as something like 140M video lecture. Then we'll click Save, and we'll click Close. And then on our desktop, which is where I saved it, you can see that we have the 140M video lecture Microsoft Management Console. We'll double click on it. We'll say yes. And then our console shows right back up. You can do other things that are outside of the scope of the lecture for now. So you can add to favorites. You can create favorites here. You can do things like, again, manage who has access to what. So for example, we could use the options and change the console mode to limited access so that I don't have the ability to change anything in here. I'm not going to do that right now, but I could definitely do this. So again, this is another function that's really a great Windows feature. It's actually in all versions of Windows, I believe after Windows 7 and higher. So something for you to play with this week as well.
Okay, let's talk about the registry. So the registry is a hierarchical database that stores low-level settings for the operating system and applications. We're going to take a look at what the hierarchy looks like here in a few minutes. So it's designed for direct access by programs and processes, and it's not really meant for manual editing, but some Windows settings can only be changed through the registry. So it's, again, not meant to be manually edited, but sometimes you have to. Case in point, we have at my office right now, we are heavily reliant upon Java. One of the really unfortunate things about Java that you've all probably run into at some point or another is that Java tends to update or prompt you for updates like every hour. That's an exaggeration, but it prompts you a lot to update Java. And since we rely on a specific version of Java, we want to prevent that from popping up on our users' machines. So the only way to do this, or the best way to do this, is to go into the registry and change the setting for the Java updater from a 1 to a 0. There's no option in the Java Management Console to turn this off, or at least to turn it off completely. So there is a registry option, however, and that's the method that we were able to use to successfully disable Java Updater on our machines. So again, the registry can be manually edited with a registry editing tool. The tool in Windows is called regedit, R-E-G-E-D-I-T, and it's included with all versions of Windows. One really important thing to note about regedit is that it does not check data type, accuracy of data, or reasonableness of entry. So we're going to take a look at why that's important here in just a second. But in a nutshell, it doesn't spell check you. So if you are making changes to a system file and you input the wrong thing or you input the wrong type of data, you could inadvertently break some feature of Windows or some application that you're trying to manipulate. So that segues into the last bullet point here. Be extremely careful when editing the registry. I like to tell people it's a dangerous place, and typically you only want to go there if you're directed there by some software developer or if you have some specific need to go there. Again, just be extremely careful. So a little bit more about the registry. The registry is extensible, which means that it can be modified and expanded upon by new hardware, software, system updates, and yourself. So it can grow. It's a living database of sorts. It is divided into 5 root keys. So you've got H key class's root, which contains information on file association. Don't typically edit this one all that often. You've got H key current user, which is it contains settings for the currently signed in user account. This one you edit frequently. You can edit frequently. H key local machine. This contains information related to the inner workings of Windows and its software. So a lot of things get written to H key local machine. H key users contains information for the user account currently logged in, as well as a pointer for the default user. So it's a little bit misleading saying H key users. It doesn't actually contain information for all users on your computer, just the user that's currently logged in, as well as the default user. Also, we have H key current config. This displays the contents of the hardware profiles for the current computer. Again, this one isn't edited all that often. Each subkey can contain one or more subkey values. So it functions a lot like Windows Explorer in that you can have a key inside a key inside a key. Or like in Windows Explorer, you can have a folder inside a folder inside a folder. So we'll look at that here in a few minutes. So a few important notes about interacting with the registry. When you are making changes to the registry, always back up the key that you're modifying at the very least. It's really easy to back up a specific registry key. All you have to do is right-click the key, and you can select Export to back up that registry key. And it backs it up in the .reg file format. To restore a registry key, equally easy. All you have to do is find where you stored that .reg file, and then you double-click it. Then it prompts you a few times, basically saying, hey, do you really want to do this? And then you're back off to the races. Last thing here, back up a registry key from the command line using the regexport command. So the syntax for this is reg space export, and then space the key name, and then space followed by the file path to where you want to save the key. So for example, if we wanted to export the key my app located in H key local machine, we would type reg space export space hklm/software/myco/my app, and then we'd put another space in, and then we type the file path. So in this case, the file path is C users timg desktop, and then appbk up.reg, and that's going to store that in a reg file on my desktop.
All right, so let's look at how to access the registry. So I mentioned in the previous slide, you can access the registry with the registry editing tool in Windows. In all versions of Windows, this is regedit, R-E-G-E-D-I-T. We'll hit enter. It's going to ask us if we really want to run it. We'll say yes. And then from here, we'll be brought to this screen. Let me go ahead and minimize this here real quick. So as mentioned in the previous slide, we do have 5 registry root keys: H key classes root, H key current user, H key local machine, users, and H key current config. And each one of these keys, just to show you how many registry keys there are, has a ton of different keys below it. So in this case, these are all the file associations on our computer. And HKey class's root has registry entries that have to do with each one of these things. Now, it's important to note that there is no manual that explains what each one of these keys does. So for all I know, this is editing the start menu. Again, it's very, very specific what each one of these things does, so it's best not to mess with them unless you really need to. So let's take a look at the HKey local machine, or excuse me, HKey current user. This one's a little bit better laid out, or not better, but a little bit easier to understand, I think. So in this case, we're going to go to HKey current user. We're going to go to software. Let's go ahead and we'll pick on Adobe here. Go ahead and go to Adobe, and you can see we've got entries for Adobe Acrobat Reader, Adobe Acrobat, so on and so forth. Let's look at Adobe Reader, and then DC. And then under here, it looks like we have a ton of different registry keys. So again, without being a software developer or the developer that developed this, I have no idea what each one of these does. So changing these could irreparably break how Adobe functions. Let's see if we can't find something useful here. So we've got one here called Home Welcome, and then we have registry values in each one of these keys. If we were to double click on one of these, we'd be able to change the value of the data. Now again, we see here that the value here is 0 and it's in hexadecimal and not decimal. We could type anything we want here. So I could type Tim, or whoops, excuse me. I could type a 1, I could type a 2, I could type several ones, and this could mean different things to whatever application is referencing this. By hitting OK, I could break Adobe for all I know. And watch this, this is the important function here. I'm going to click OK. I have no idea if this value is correct. I'll click OK, and the value changed. But one thing you should have noticed, I didn't get prompted saying if I really want to make that change. I also didn't have any sort of type check or anything like that telling me that I couldn't do that, even though this is probably going to break some function of Adobe. So it's really important when you are editing the registry to back your registry key up first. And the easiest way to do this is to simply right click on one of these folders here, one of these keys. We're going to click export. We're going to give it a name, so we'll call it 140M backup lecture. Click save, and just to show you what happens, I'm going to go ahead and I'm going to delete this key since I already backed it up, and we can see that it disappears from our list here, so it's not there. I hit F5 here to refresh just to show you it's definitely not there. And we're going to go to the desktop here. We're going to find our registry key, 140M backup lecture. We're going to double click it. It's going to ask us if we want to run this. Now it's going to say, hey, this might unintentionally change or delete values. Do you really want to run this? Since we created it, we're going to click yes. But if this was from a source out on the internet, we definitely don't want to click this. Unless you're very, very, very confident that it's from a trusted source. So we're going to click yes. It's going to say, hey, we added the key back. Click OK. We'll go back to our registry, and look at Home Welcome is back. So it's as simple as that. It's pretty straightforward to back up a registry key. Again, I think the most important thing to take away from this is there's no checking to make sure that the registry key is valid. There's no checking to make sure that the edits you're making are valid. And you can delete things willy-nilly if you wanted to. So it's really important that when you come in here for a specific reason. Usually you're directed here by a software developer. And you make your you back up your registry key before you make your change.
So let's talk about the alternative boot menu. So Windows provides an alternative way for you to boot up Windows. And most often you're doing this specifically because something has gone wrong, so for troubleshooting. So booting into Windows has changed in Windows 10 because Windows 10 relies a lot more on UEFI BIOS. So older versions of Windows allow you to just simply press F8 during the startup. So this is before the Windows splash screen comes up to enable access to the advanced boot menu. And this is not, again, this is not the case in Windows 10. So again, this changed because widespread use of UEFI BIOS and solid state disks. So to do this now, what you want to do is when you're inside Windows, or with the operating system fully booted, you're going to press the Shift key while clicking the Restart button in the menu, or in the Start menu, and then this will boot you, the next time it boots you into Windows, it will boot you into the Advanced Boot menu. You can click Troubleshoot, Advanced Options, and then Startup Settings. Once the system reboots, you'll actually see a blue menu. This isn't a blue screen of death, it's a blue troubleshooting menu. You'll see that pop up, and then you'll be able to click Troubleshoot, Advanced Options, and Startup Settings to get into the Advanced Startup menu. So once you've rebooted your machine into the Advanced Startup menu and you've accessed the alternative boot menu, there are going to be several different options that are available to you. So let's just go through them one by one here. Enable debugging. It's basically the same thing as downloading that checked/debug build from MSDN, or excuse me, from DreamSpark. Basically, what this option does is it enables extremely verbose logging, and it's really only useful for software developers. Software developers can use it to see how their software is interacting with the operating system. So unless you're a software developer, you probably won't be using enable debugging. Enable boot logging will log all of the drivers, software, etc. that starts up when Windows starts, and then it will write it to a log file. Typically, this is the NBTB log file. Or excuse me, NTBT log file, or log.txt file. Next one, enable low resolution video mode. So if you've installed a new graphics card, sometimes you'll run into this issue. Your resolution the resolution of your monitor may extend beyond the resolution that it can actually display. So when that typically happens, your monitor is going to go blank and Windows will still be running, but you're not able to interact with it in any meaningful way. So enabling low resolution video mode will scale the resolution to either 800 by 600 or 640 by 480, and then that will allow you to get around the high resolution issue. So that's good if your machine is obviously still functioning, but you can't see anything on the display. Enabling low resolution video mode may just solve your issue. Enable safe mode. So this one's probably the most important one that you'll end up accessing. So safe mode allows you to boot into a menu. Excuse me, allows you to boot Windows in an extremely limited form. So rather than load all your applications, all your software and everything, it only uses the files it needs to boot Windows and nothing else. In fact, if you click enable safe mode without networking, so this is the first option there, then it's not even going to turn on your network interface cards. You won't have network access. So it's just the bare minimum it needs to boot Windows. And where this is really useful is when you're trying to troubleshoot some piece of software that might be causing an issue. You can boot into safe mode, see if the system functions. If it does, then you can start up the software one by one to see which particular software is causing performance issues. I did this once to solve a performance problem related to Norton antivirus. We couldn't figure out exactly what was causing the problem, but the machine was horrendously slow. So what we ended up doing was we booted into safe mode. We went through this person's applications one by one, and then when we started up Norton, lo and behold, Norton was taking up 100% of the system resources, and upon uninstalling that, the machine was able to function just fine. So safe mode is a great place to go for troubleshooting because it only loads the bare minimum. Safe mode with networking enables networking, so if you need to get on the internet or access network resources when you're troubleshooting, Safe mode with networking is the option to choose. And then safe mode with command prompt will automatically launch the command prompt when you launch safe mode for the first time. Disable driver signature enforcement. This option is really, really useful if you have drivers that are not signed by Microsoft. So one of the things that Microsoft does is they work really closely with hardware manufacturers to make sure that the drivers that the hardware manufacturers are producing aren't going to harm Windows or Microsoft users in any meaningful way. So to do that, to ensure that the drivers are vetted proper, or to ensure that the drivers are going to work well for each user, Microsoft puts them through kind of like a vetting process. And once the vetting process is complete, they get signed by Microsoft. So sometimes you'll want to install a driver that is not signed by Microsoft. You can do this for any number of reasons. Pre-production drivers, if you want to install a custom driver, you'll need to disable driver signature enforcement, because otherwise you'll get a nasty pop-up message that says you can't install it or it won't work. Disable early launch anti-malware protection. This option's really useful if it's really only useful if you're having trouble booting Windows related to like a false positive with some malware or piece of software. I had this happen to me not too long ago. I installed a new piece of software, and then when I rebooted, I wasn't able to get back into Windows, and that's because this early launch malware, anti-malware protection was flagging that piece of software inadvertently as a virus. So it's useful because some viruses will only execute upon startup, or they even do it prior to startup. So this option is really useful to leave enabled if you're concerned at all about viruses. It basically stops them from propagating on startup. But sometimes there's false positives, and sometimes you have to disable it. This last option is useful if you have a computer that you're working on and maybe you're leaving for the day and you know that it's going to restart, but you want to shut it off anyways. Disable automatic restart after failure. So once a machine blue screens, it's set up to automatically restart itself. And if you run into an issue in which your computer blue screens and then on startup it blue screens again, it's going to reboot itself, and then it's going to blue screen again, and then it's going to reboot itself, and it's going to blue screen again. So it basically goes into this infinite loop of boot cycles. So disabling automatic restart after failure will prevent your machine from starting back up automatically after a stop error or a blue screen of death. So that's pretty much that's it for this lecture. I hope you learned something as far as troubleshooting goes. Again, a lot of these troubleshooting tips or these troubleshooting things we learned about in this lecture are things that you can apply to not only computers. You could apply them to other aspects of your life as well. So I hope you learned something. I hope you're able to apply these to other things in life in addition to computers, or in addition to the Microsoft world even. So again, this week I'd suggest you go through the various tools that we discussed. Try to get into the alternative boot menu. Definitely mess around with the registry, but of course make sure you back up your changes or back up anything before you make changes. And in general, just try to do some troubleshooting. I think that should do it. Again, let me know if you have any questions. I'll definitely be here. Thanks.